Hi friends! In our last section, we learned how to find the area and perimeter of various 2D figures, including the trapezoid, parallelogram, rhombus, regular polygons, and irregular polygons, and so on and so forth. So, on the basis of what we will be doing, from this, we have some questions. Let's start. Here we have our very first question, which is the trapezium, whose area is given as 480 meters squared. And we have to find the height of this trapezium, or we have to find the distance between the two parallel sides. And we are given the length of the two parallel sides is 20 meters and 44 meters. So let's solve it. We know in the case of any trapezium, in order to find the area, the formula is half multiplied by height times the sum of the two parallel sides. So let's use these values in the formula. A is 20 and B is 44. The area is 480. So putting this into the formula, we get 480 times half times height times 20 plus 44. 2 is getting divided on the right-hand side, so it will be multiplied on the left-hand side. So you get 2 times 480, that is 960. That is equal to height times 64. Now we divide 960 by 64 to get the height. And it equals 15. So the height is 15 meters. So we have calculated the height of this trapezium. Let's move on to our next question. We have a rhombus, and we have to find the area of this rhombus, and we are given the length of the two diagonals. One diagonal is 16 centimeters, and the other one is 30. Area of the rhombus is calculated with the formula half multiplied by diagonal 1 times diagonal 2. And here we are given the length of the diagonals, so we can put it into the formula. So it will be half multiplied by 30 times 16, and you will get 240 centimeters. So you will get 240 centimeters squared. Let's move on to the next question. We have a regular hexagon with sides of 5 centimeters, and we have to find its area. Method 1. We have a formula for finding the area of every regular polygon. Half multiplied by S multiplied with A, and the whole thing multiplied with N, where S is the side length of the hexagon, N is the number of sides of the polygon, and A is the apothem, that is the perpendicular drawn from the center of the regular polygon to any side. Now let's solve the question with this method. We need to have the length of the apothem, and apothem in this case is 4.26666 or 4.27. Putting the value into our formula, we get half multiplied by 5 multiplied by 4.27. And then multiplied by 6. And calculating it, we get 64.05, or you can round it to 64 centimeters squared. Let's move on to the second method. You can divide this hexagon into two different shapes so that you can calculate the area of the hexagon. One method, you can draw a line joining the point A and D. So we have divided the hexagon into two trapeziums. This has two parallel sides, EF and AD, and the other one is ABCD, which has two parallel sides, AD and BC. So these are the two trapeziums. We'll find the area of one trapezium and then multiply it with 2 to find the total area of the hexagon. Because these two trapeziums are congruent figures. They have the same lengths of the parallel side and the other sides. So that means that they are exactly the same. All sides measure 5 centimeters. How do we find the area of the trapezium? The formula for finding the area of a trapezium is half multiplied with the height times the sum of the two parallel sides. In order to find the area of the trapezium with this method, we are missing two of the figures. One is the height, and the second is the length of the side AD. On the meeting, you will get the length of the side AD, and it will be 11 centimeters. And the height of this trapezium will be 4 centimeters. Now, putting these values into the formula, you can calculate the area. We'll multiply half with 4 times 5 plus 11. And you will get 16 as the sum. Then you will get 32 centimeters. And finally, 32 centimeter squares is the area. So that is the area of one trapezium, and there are two in this hexagon. I repeat, why are they congruent? Both trapeziums have one side that is common, that is congruent with the other. And they both have side lengths of 5 centimeters. And the other parallel side, EF and BC, and both the trapeziums are also the same. Both are 5 centimeters. So all sides of the trapeziums are the same. Therefore, they are congruent. So you can multiply 32 with 2 to find the area of the hexagon, and you will get 64 centimeters squared. So 64 centimeters squared is the area of this hexagon. And you can calculate it using the other method, method 1. Now here we have our next question. We have a trapezium-shaped table whose parallel sides are 2 meters and 3 meters in length. And the distance between the two parallel sides is 0.5 meters. This is the height. We know the formula for finding the area of the trapezium is half multiplied by sum of the two parallel sides times height. We are given that the parallel sides are 2 meters and 3 meters, and the height is 0.5 meters. So area is half multiplied by 2 plus 3 times 0.5. That equals 5 over 2, or 5 over 10. Therefore, the area is 1.25 meters squared. Here we have another question. It is again a trapezium. Area is 34 centimeters squared, and we have to find out one of the parallel sides. The other is 10 centimeters long, and the height is 4 centimeters. We know the area of the trapezium is half multiplied by b plus a times h. So let's put the values into this formula. A is 10 centimeters, H is 4 centimeters, and area is 34 centimeters squared. Therefore, 34 equals half times B plus 10 times 4. We will multiply 34 with 2. 34 times 2 equals B plus 10 times 4. Now, since 4 is multiplied on the right-hand side, it will then get divided on the left-hand side. And then it becomes 17 equals b plus 10. Then you will subtract 10 from 17. So 17 minus 10 equals b. And therefore, b equals 7 centimeters. I repeat, in any trapezium, the formula for finding the area is half multiplied by b plus a times h. And the height is the distance between the two parallel sides. Whenever you are given any of these three values out of the 4, you can find the fourth value. Like in this question, we have been given 3 values: the height, the length of one of its parallel sides, and finally the area. So we put these three values to finally get the fourth value. So you can be given any three values, and they can be the two parallel sides and height, and then you're supposed to find area. Or you can be given the area and the length of the two sides, but then you need to find the height. Let's move on to the next question. The diagonal of a quadrilateral shape field is 24 meters, and the perpendicular drawn on it from the remaining opposite side is 8 meters and 13 meters. Find the area of the field. We can see that it is a quadrilateral divided into two triangles with the help of the diagonal. We can add up the two areas of the triangles to get the final area of the quadrilateral. Area of the triangle PSQ is half times base times height, where height is 13 and the base is 24. And area of SQR is the same. It is half times 24 times 8. Area of triangle SQR has the same formula. We plug in the values of its height and base, 24 times 8. So then area of PSQ is 156 meters squared, and SQR is 96 meters squared. And adding them up, we get 252 squared. That is the area of the quadrilateral. Let's move on to the next question. We have a rhombus. Both diagonals are given. One is 15 centimeters and the other is 24. We have to find the area. We know when the diagonal of the rhombus is given. Formula for finding the area of the rhombus is half times d1 times d2. That is half multiplied by the product of the two diagonals, so it becomes half times 15 times 24. The answer is 180 centimeters squared. So the area is 100 centimeters squared. We have to find the area of a rhombus whose side is 10 centimeters and altitude is 9.6 centimeters. And one of the diagonals is 16 centimeters. Let's solve this question. First part of the question said we have to find the area of the rhombus. Area of the rhombus can be calculated with two formulas, either the base times height, because it is a parallelogram, or half times d1 times d2. If you're given the length of the two diagonals, you use the second formula. However, we are only given the length of one diagonal, so we will be using the formula base times height. Base is 10 multiplied by 9.6, which equals 96 centimeters squared. Now we use this area to calculate the other diagonal, using the second equation for the area of the rhombus. The formula is half times d1 times c2. 96 is the area, and that equals half times 16 times d2. Therefore, d2 is 96 times 2 divided by 16, and that equals 12 centimeters. So the length of the diagonal 2 is 12 centimeters. I will repeat this question. The question is that we are given a rhombus shape, and here we have to calculate the area, where the side is 10 centimeters, and the height is 9.6 centimeters. The rhombus is a parallelogram, so we can use base times height to find the area, or half times d1 times d2. But as we are only given one diagonal, we use base times height. Base is 10, and height is 9.6. So the area is 96 centimeters squared. Now, to find the diagonal, we use the area that we calculated and plugged it into the formula half times d1 times d2. And then we get 12 centimeters. The floor of a building consists of 3,000 tiles. They are rhombus shaped and each of its diagonal is 45 centimeters and the other is 30. Find the total cost of the flooring when the cost per centimeter squared is $0.04. Let's solve it. Review what we have already been given. We are given that the number of tiles is 3,000. Diagonals are 45 centimeters and 30 centimeters. And the cost per centimeter squared is 4 cents. So we can calculate the area of one tile by the formula half times d1 times d2. So we will get 675 centimeters squared. Then we calculate the area of the whole floor because we are given the area of one tile and the number of tiles. Area of the floor is number of tiles times area of one tile. 3,000 times 675, which equals 2,025,000. Now we calculate the cost of the flooring by multiplying the cost per centimeter squared, which is $0.04, times the area of the floor. So we get $81,000. That is the total cost of flooring. Here we have our next question. We have a trapezium, and we have to calculate its area. One parallel side is 50 centimeters, and the other is 100. That is, one is x, and the other is 2x. We are also given the distance between the two parallel sides. It is 100 centimeters. That is the height. Now we have to calculate the area of the trapezium. We know the formula for the area is half multiplied by a plus b times height. We can put the values that we are given into the formula. We will get half multiplied by 50 plus 100 times 100. Then we get 7,500 centimeters squared. So the area of the trapezium will be 7,500 centimeters squared. Now here we have a regular octagon. We know the area of a regular polygon is half multiplied by SA into N, where A is the apothem, but we are not given the apothem in this figure, so we'll be using the other method. We are given the height, which is 4 centimeters inside of the octagon. We are also given that one of the parallel sides is 11 centimeters and the other is 2. The side of the octagon is 5 centimeters. So we can divide this into 2 trapezium and 1 rectangle. So we can calculate the area of the 2 trapezium and the rectangle, and then sum it all up to get the final area. Area of trapezium ABCH is half times A plus B times H. Plugging in the values, we get half times 5 plus 11 times 4. And finally, we get 32 centimeters squared. And then for the rectangle, we get area is length times width, so 11 times 5. So then we get 55 centimeters squared. These two trapeziums are equal. They are congruent figures. So they have the same measurements. You can see that one parallel side is 11, height is 4. So trapezium GDEF will have 32 centimeters squared as well. And then adding all three areas together, we get 119 centimeters squared. This is the area of the octagon. Now we have our next question. We have a diagram of a photo frame where the dimensions of the outer frame are given. We have to find out the area of the photo frame. Let's solve it. Let's name the vertices of the photo frame. We can name them as A, B, C, D for the outer ones and E, F, G, H for the inner. So we have given them all names. Now we will be finding the area of the photo frame. We can see that we have 4 trapeziums in the photo frame. The inner and outer sides are parallel to each other. And if you look at the figure A, B, E, F, it is a trapezium because sides EF and AB are parallel, where it has one pair of parallel sides and the other, that is, they are not equal to each other. So we can find the area of the 4 trapeziums to find the area of the photo frame. Let's start with trapezium AEFB. We are given the length of the side AB, it is 24, and EF is 16. We are also given the total height of the frame. It is 28 centimeters. and the inner height, that is 20 centimeters. And the inner height, that is 20 centimeters. So we can find out the height of this trapezium by subtracting this inner side, that is 20, from 28, and then dividing by 2. Because height of this trapezium will be 28 minus 20 divided by 2, since there are 2 trapeziums on each side. So height is 28 minus 20 divided by 2. Now we have a formula for finding the area of the trapezium. That is half times a plus b times height, where a plus b are the sums of the 2 parallel sides. So that would be 24 plus 16 times the height, which is 28 minus 20 divided by 2. So area of one trapezium is half times 40 times 4, which equals 80 centimeters squared. Similarly, you can find the area of all the trapeziums. Let's do it. What will be the area of the trapezium DHGC? We just have to repeat the process. Area is half times a plus b times h. A plus b in this trapezium would be 24 plus 16. And then height is 28 minus 20 divided by 2. It is the same. So the area would also be 20 centimeters squared, because all these values are exactly the same as it was in trapezium ABEF. Now let's move on to the other 2 trapezium, which are also equal. We will be finding the area of one trapezium and then multiply it by 2. These 2 trapeziums are BFGC and AEHD. Area of trapezium AEHD is half times a plus b times height. A plus b is 20 plus 28. And the height is 24 minus 16 divided by 2, because you can see that the height of this trapezium would be the difference of these 2 sides. Side DC and HG, divided by 2. Because DC minus HG is the total height, and then we have to divide by 2 to get the height of the 2 trapeziums. Now multiplying half times 20 plus 28 times 4, we'll be getting 68 centimeters squared. So the area of the trapezium AEHD is 68 centimeters squared. This will be the same area for BFGC because they're congruent. So the total area of the frame would be the sum of all these 4 trapeziums, which will be 80 plus 80 plus 68 plus 68. Therefore, in total, we will get 296 centimeters squared.